What happens in the brain when we face adversity? And why do two people with the same hardship walk away with such totally different outcomes? Is resilience something that you're born with, or is it something your brain can develop? And if so, how? What does any of this have to do with the diving bell and the butterfly, or using magnetic fields to zap the brain? Or the less famous partner to the brain's reward system, or what seemingly unrelated disorders in psychiatry all have in common. Welcome to Inner Cosmos with me, David Eagleman. I'm a neuroscientist and an author at Stanford, and in these episodes, we sail deeply into our 3-pound universe to understand why and how our lives look the way they do. Today's episode is about resilience. We all know someone who's been through hell and somehow comes out standing. Maybe you know a person undergoing chemotherapy who still manages to raise a family and be a good parent, or a refugee who rebuilds their life from nothing, or a friend who keeps going after losing her job. There's something about resilience going on here that's different from what a lot of other people would do in the same situation. We're thinking about this one, a young man who gets an early onset motor neuron disease and slowly ends up completely paralyzed in a wheelchair and eventually loses his ability to speak. But he keeps on plugging along and eventually ends up becoming one of the premier mathematical physicists in the world. This is the story of Stephen Hawking. How did he stay so resilient in the face of a slowly creeping disease that ate his body but didn't seem to slow him down? That kind of drive, that kind of adaptation, it raises the question, what enables some people to keep going when everything falls apart? What is human resilience made of? In this episode, we're going to answer this question by diving into the brain, and I'm going to do so with my colleague and friend, Jonathan Downar, who's been on Inner Cosmos before, and he's one of the most compassionate and insightful thinkers that I know. He has an MD and specializes in psychiatry, and he also has a PhD in neuroscience. And he's become one of the world's experts in transcranial magnetic stimulation, which is a technique that we'll come back to in a minute. Now, Jonathan was on Inner Cosmos about a year ago to talk about depression, and that episode moved and inspired a huge number of people. So I've wanted to sit down with Jonathan again to zoom out the camera one notch to talk about an idea, a change in focus, the idea that clinical depression is actually one expression of a more fundamental issue, one that has accidentally surfaced as neuroscientists around the globe have performed hundreds and hundreds of individual studies and then looked at the emerging shape that all of these studies were pointing to. What we'll learn today is an issue that sits right at the center of our lives. So let's dive in with Jonathan Downar to understand it. So Jonathan, we've all known people who are in very terrible circumstances in life, and yet they figure out a way to keep going. So we might classify this as resilience. So tell us about resilience.
Yeah, so it's a fascinating topic to get into. I think a good example to start us off by way of illustration, you and I in our textbook talked about the case of Jean Bobby, who was the author of The Diving Bell and the Butterfly. I really like his example because he had an absolutely horrific situation in which this was a successful author and editor of the French fashion magazine, Elle Magazine. Yeah. And he unfortunately suffered a tiny little stroke in his brainstem that left him with this syndrome called locked-in syndrome. And for those who are hearing about that for the first time, it's a horrible syndrome where the output passages from the output tracts from your brain down to the spinal cord and the muscles are just severed by the stroke. So you're perfectly awake, you're perfectly conscious, you can feel sensations, but you can't send any signals out to your body. And there's no recovery. He was then bedridden, and the only part of his body he could move were he could blink, and that was pretty much all he could do. And with the assistance of some of the people who worked with him, he would use a blinking code to specify letter by letter what he wanted to say.
Specifically, the assistant would read out the letters of the alphabet in order of their frequency. And then when she got to the right letter, he would blink his eye and she would write down that letter and then start the process over again.
Yeah, and so the fact that he was even able to, like, I don't know what would happen to you or I or most of the people I know if they were in that situation. Certainly, I mean, imagine having an itch which you can't scratch because you can't move, or a pain in your leg or a cramp in your leg that you can't do anything about for hours. It's very hard to maintain a positive attitude in a situation like that. And yet he was able to laboriously blink out an entire book describing his experience. Which
the
was
diving
called,
bell of the butterfly.
Exactly.
Yeah.
So when I think about the fact that, to me, the most remarkable part about this is not the stroke or the fact that there's an assistant with this amazing blinking code. To me, the astonishing part is the fact that there's a resilient spirit in there that's capable of doing that is laying there in this bed and yet somehow has the patience and the resilience and the inner fortitude to do something like that.
So what is that about?
So there are a few different ways of looking at resilience. It's been studied to death, and there are whole books that have been written on it. You can talk about psychological sources of resilience. You can talk about cultural practices and interventions and therapies that support it. You can talk about social practices that support it. What I want to dive into a little bit is the actual neural circuitry behind it, because we are learning a lot about what that neural circuitry is. And it turns out that there are indeed specific brain circuits which support our ability to be resilient. So for example, a person who suffers a terrible stroke, if these circuits are preserved, then the person can actually function a lot better than you would expect, given the circumstances they're in. And then surprisingly, if those circuits are damaged in the stroke, the person may have minimal physical limitations and yet is not functioning at all, is sort of emotionally always getting stuck on things, cognitively always getting stuck on things, and just not able to get up and start moving. So I think what would be interesting to get into a little bit is the circuitry that we've been able to delineate behind the general ability to be resilient to life stresses and challenges and the general ability to function.
And just before we get into the details of the circuitry, what is the variation in the circuitry across the population?
Yeah, so that's fascinating. There's been a lot of studies done on that using techniques, using MRI scans. So for example, you can have a person go in the scanner and you can actually map the thickness of their gray matter across the whole, right, using a technique called voxel-based morphometry. So they take all the little voxels in the scan and they look at how thick the gray matter is in different areas. And they can compare people who have more resilience versus less resilience. There was a famous study done, I guess about a decade ago now, where they did exactly the question we're asking about. They took a whole bunch of people who had suffered horrible adverse childhood experiences. There's actually a psychological questionnaire called the Adverse Childhood Experiences Questionnaire. So all these people, had been through horrible traumatic experiences, and yet a subset of them had never gone on to develop post-traumatic stress disorder or depression or any other sort of classic, axis 1 mental disorder. And the question was, what's going on with them? It turned out that there were specific areas of the frontal lobes that had thicker gray matter in these areas we were pinpointing. Specifically, there's an area we can get into called the left dorsolateral prefrontal cortex, but essentially a network of areas in the brain who seemed, if you just had by luck of the draw, you happened to have more gray matter in these areas, then you were more likely to be resilient to even quite horrible adverse childhood experiences.
And is it luck of the draw, a genetic issue, or is it environmental practices or social practices?
Yeah, that's a really good point. There are, the literature on resilience suggests that there's a lot to this. So, although there is some genetic component to resilience, that I think that is greatly overshadowed by one's environment and one's psychology and one's upbringing and the practices that one implements. Early adverse childhood experiences are really bad for people's resilience, whereas growing up in a supportive supportive childhood environment and having social supports and sort of a calm parenting environment and all the rest of it can often provide a person with quite a lot of resilience that they can tap into later on in life.
Yeah. Although there are, like everything, it's a gene-environment interaction. There are these studies done by Stephen Suomi with monkeys where he is looking at these monkey troops, and with half the adolescent monkeys, he has them with their mothers, and the other half he has them just with their peers. So they're raised with peers, and just like in junior high or high school, monkey peers are mean to one another. And so he looks at who ends up doing well and who doesn't. And it turns out it's not as obvious as you would think. It turns out that there are genetic predispositions that cause some of the monkeys in the bad group being raised with their peers to still do fine, and others not. So there's definitely an interaction between how you're raised and what you come to the table with genetically. So let's jump into what you see when you're looking at this in the brain scanner. What are these prefrontal areas that you're talking about?
So I think that might be a good place to start. So on the one hand, let's say we have this technique called voxel-based morphometry that's capable of pinpointing areas of gray matter that are thicker versus thinner in certain groups of people. And let's say we've used that to find people who are unusually resilient to developing axis 1 disorders despite adverse childhood experiences. The flip side of that would be looking at people who do have axis 1 disorders and saying, okay, and this was an enterprise that began in, I guess, around 2010 or so on. They started being able to gather up big data sets of lots of people who had succumbed to depression or bipolar disorder, OCD, substance use, anxiety disorders, PTSD.
And this is what you mean by axis 1 disorders.
That's axis 1 disorder, exactly. So the sort of the classic sort of psychiatric disorders. DSM-1 is the Diagnostic and Statistical Manual, and so the axis 1 of that is just one way of describing formal clinical psychiatric disorders. So this was a team led by Amit Etkin at Stanford University, and Madeline Goodkind was the first author. And in 2015, they gathered up over 200 studies that had been done, or close to 200 studies that had been done looking at the thickness of gray matter across all these different disorders. And they asked a really interesting question. Are all the different disorders like OCD and PTSD, are they completely different? Do they all involve different brain circuits? Or is there some common element? Like if you did a Venn diagram and overlaid them all, is there some common element to all the brain disorders that we have lumped into the basket of psychiatric disorders as opposed to, neurological disorders?
And it's so amazing, by the way, that we can do this now because we have enough brain scans from enough patients with different disorders that for the first time in history, we can ask that question.
It was, absolutely.
So what did they find?
Fascinating. So they turned out that yes, indeed, if you overlapped all the maps of all these 200 different studies involving, I think, close to 7,000 patients versus healthy controls, there were indeed some areas which were universally thinned out across all these different disorders. And as you might expect, they belong to the same network that this resilient network was, except it was in the other direction. So people with quite thick gray matter in this network of regions were resilient to disorder. And on the other hand, if you looked at people who had these disorders, PTSD or anxiety, one common element they all had was that this specific network of regions was a little bit thinner in terms of the gray matter. There are a bunch of different networks in the brain that perform various functions. Some of them move your upper body or your lower body or do vision or hearing. This particular network had an interesting name. It's called the salience network. And so what was neat about this, it popped out the common element across all these different disorders when people lose their resilience is the salience network. And on the other hand, if your salience network is intact, then you tend to have this resilience.
So help us understand this a little bit more. So if you have less resilience, how does that connect with psychiatric disorders?
So that's really, I think that's a really great question and the right way of putting it. So the salience network, it helps to understand what the salience network's function seems to be. And what was neat about discovering that the salience network was involved is that separately, people had been studying the salience network for 15 years. I accidentally did my PhD on it back in the late 1990s before we really knew what it was. But its job seems to be a thing called cognitive control, the ability to self-regulate your thoughts and your behaviors and your emotions. What's unique about it in terms of the brain regions it involves is it has some brain regions that are part of the limbic system, the so-called emotional system of the brain, but it also has some areas that are part of the brain's kind of executive function and cognitive system. So it's out of all the various dozens of brain networks that are there, it uniquely seems to bridge between the limbic system and the cognitive system, between sort of reason and emotion. And you will see people activating it when they have to inhibit a particular thought in order to do, or a prepotent response. So a classic example of that would be the go, no-go task, which is a task where people have a signal that tells them to press a button, and then another signal says, no, wait, don't do that. And so you have to inhibit that predisposition.
So for example, if the banana comes on the screen, I pound the button, and if the strawberry appears on the screen, I have to not hit the button.
That's a great example.
Okay.
Yeah, that'd be it. Another example would be the classic Stroop task, which in the Stroop task, this is a tricky one if you ever have to try it. They have them online if you ever want to go and try them. The word blue will be written in red ink, or the word red will be written in green ink. And you have to not say the word, which is the thing you want to do, but you have to actually push past that prepotent response and say the color of the word, even though there's an interference effect there. So the Stroop task and all these things volitionally activates your cognitive control capacity. It essentially allows you to stop ruminating and to focus on what kind of response you're going to make. So the salience network will kick in. If a person, I'll give you an example. If you, for example, got bored with what I was saying right now and your mind started to wander to yesterday or tomorrow, or I usually say this in lectures, and it's a room full of people, so you could always see the people, like some people are paying attention. It's totally natural. It's very hard to focus your attention for a long time. So people start thinking about something else. And then maybe suddenly I say something interesting and their attention comes back again. At that moment, when you stop mind wandering and you return to the present moment, your salience network, bing, is activating at that moment. For people who have done mindfulness meditation, we've all experienced this. Okay, I'm going to be mindful. I'm going to pay attention to my breathing. And then after about 3 seconds, your brain starts wandering off to something you have to do later that day or whatever. And you wander and wander. And then after about a minute, you're like, oh, actually, I wasn't supposed to be doing that. I'm supposed to be paying attention to my breath. And at that moment of mindfulness, you return. So at the moment of mindfulness, bing, again, your salience network comes on as you break the train of thought. So we can imagine that as we go through life, we're often not in the present moment. We're ruminating about the past or the future or something else. But the moment that we snap out of it and return to the present moment, the salience network seems to activate every time that happens. So you can imagine what would happen if the salience network goes down. Mm-hmm. If you lose that capacity to easily snap out of things, then your ruminations will just keep going and keep going and keep going. And the minute that you can't snap out of things, all of a sudden it's harder to function, right? So, all of us, if we're faced with a stressful situation, let's say we start worrying about it and thinking about something horrible that's happened, if we lost someone important to us. But as long as we can snap out of that thought and return to our task or our work or whatever we're doing, we don't have an axis 1 disorder. We have stress, we have distress, but we don't have disorder. But the day you can't snap out of it again is the day you flip over into having a disorder.
So with this understanding coming into focus, what kind of therapeutic approaches are there?
Beautiful. So let's go to that. So let me also tie that back to resilience, because I'll say resilience has a few different, as we start to tease apart the circuitry, we start to realize that resilience has a few components to it. This isn't the only circuit behind resilience, but one of the circuits behind resilience is this salience network and its role of cognitive control and the ability to snap out of mind wandering and rumination. So that thing we call cognitive control or cognitive flexibility is one of the ingredients of resilience. And it is one that can be enhanced over time, as you say. One of the classic ways to enhance it, we know that, as I mentioned, during moments of mindfulness, that the salience network is engaged. So people who wish to enhance their resilience, mindfulness-based stress reduction and mindfulness-based cognitive therapy are tried and true, centuries old, maybe thousands of years old methods that if you spend years and years practicing, you can strengthen your capacity to be in the present moment, or at least return to the present moment when you need to, and to maintain yourself there. When you're sitting there meditating for 10 or 20 minutes, and every time you catch yourself and bring yourself back, you can think about that as one rep. It's like one sit-up of this system. And so the idea behind 10 years of mindfulness practice is you're going to do a whole lot of sit-ups, and at the end that system is going to be fairly strong. So
we have mindfulness meditation is one way to practice this. How else are you thinking about this from the neurological point of view?
Yeah, I think that's great. So so that's exactly it. So that's one way of doing it. When people there are evidence-based psychotherapies like cognitive behavioral therapy, and that's a little bit different from mindfulness. You're not merely returning to be present with whatever feelings or thoughts are there, but the trick is when you get into a difficult situation and your emotional state goes out of control or your behavior goes out of control. In cognitive behavioral therapy, we teach ourselves to reframe situations or thoughts in a different way. So we're actually exerting cognitive control to look at the situation a bit differently and figure out whether our emotions and our thoughts are proportionate to the situation or disproportionate, and then try and bring them back again. And that also involves activating these regions. So those are tried and true methods that have been out there. I'm not aware of any specific medications that in a targeted way boost these things. So there are medications that help with axis 1 disorders, but I'm not aware of a medication that specifically does this one thing of enhancing one's cognitive control. Stimulants for some people and things like ADHD, when the area is just a little underactive, there are certain groups of people who find that they gain cognitive control on, people with ADHD, for example, may find that medications enhance their ability to exercise or exert cognitive control.
But one of your areas of expertise is transcranial magnetic stimulation.
Yeah.
So tell us about that.
Thanks for being one step ahead. That's exactly where I was going with this.
So first, for the benefit of the listenership, tell us what TMS is, and then tell us how it applies here.
Perfect. Okay. So right now we've got this target circuit in the brain that we'd really love to strengthen, because if we could strengthen it for people, they would have more cognitive control and they'd have more resilience and so on. And medications don't do it for most people, and therapy takes a really long time, and not everyone has the capacity to do it. But if we could somehow stimulate that area and turn it on over and over again, like do the sit-ups for people, then we could be able to strengthen it. And the method that we're using successfully to do that right now is called transcranial magnetic stimulation. TMS is the short form. It's a method for stimulating the brain non-invasively. So in the old days, if you wanted to stimulate the brain, you had to do surgery, open up the skull and use an electrode to stimulate the brain. Nowadays, we can do that non-invasively using a device that stimulates the brain through the skull using powerful, focused magnetic field pulses. So little inductor paddles placed over the target region of the brain, and it applies little quick pulses. It's powerful enough that if you apply the little pulses to the area of your hand that moves your thumb, for example, you'll actually see the person's thumb move. And I think you and I have gone through that as a little demonstration. And it was discovered back in the 1990s that if you do this not once or twice, but if you do this hundreds of times, you can strengthen the circuits that you're stimulating via the mechanisms of neuroplasticity, which of course you've discussed elsewhere at length. The neurons that you fire together will gradually wire together. So when you deliver TMS to any area of the brain, not only do you activate that area, but the other areas it's connected to will also light up, and they all fire together and they all wire together. So you can sort of do hundreds of sit-ups for a person in about 3 minutes of TMS using these sequences of pulses. It's been known for a long time that TMS to regions like the dorsolateral prefrontal cortex and so on. Back in 1995, it was first demonstrated that this can be useful in treating depression. And then it turned out to be useful in treating other things like anxiety, and other targets turned out to be useful in OCD and PTSD and binge eating disorder and bulimia nervosa and lots of other conditions. Interestingly, when we look back at what areas we'd been stimulating back in the 90s and later on, it turned out that a lot of the areas we were activating with TMS corresponded very nicely to this network, the salience network, which had been active across many different disorders. For those of us in the field, it solved a bit of a mystery where we come in and say, look, I thought we were just trying to treat the patient. When I opened my TMS clinic in 2010, we kept seeing this. We'd have a person who came from the eating disorders clinic. Oh, well, but you're depressed, so let's see if we can help you. So we treat their depression. And they come back in and they say, well, doc, you didn't tell me my bulimia was going to go away. And it's like, well, that's interesting. I'll have to think about that. And then you'd have a person who came in for depression, but their bigger picture, they were a veteran with PTSD, and they come in and say, I'm not having flashbacks anymore. I can walk into Walmart now without having panic attacks, and my anxiety is way down. You'd have other people who'd walk in and say, I took a mindfulness course once and I just couldn't do it, but I noticed after the TMS, now I can do mindfulness. Or I say, I took a therapy course once and I tried to learn how to do CBT and I tried the techniques and, I tried for 2 years. I was like teaching it to my roommate and she could do it, but I couldn't do it. But now after the TMS, I can do it now. Like it actually works now. So there's a synergy between these areas of the brain and our ability to stimulate them with TMS. And what we've noticed as we stimulate these areas is it turned out to be very hard to just treat the person's depression or just treat their PTSD. If it kicked in and worked, a lot of things got better. And it was really fascinating is what they would come in and you would ask them, okay, I see the numbers on your scale are down, but just tell me in your own words, what's different now? And they say, it's really weird. Traditionally, I'm constantly ruminating about my body image all day. Like I can't stop thinking about my weight and I can't think about the way I look. And then I noticed that, I had and then someone made a comment, my aunt made a comment about my appearance. And normally that would have ruined my entire day. And I would have been still ruminating about it when I went to bed. And it was really weird. I noticed an hour later that I just wasn't thinking about it. I was kind of over it. I was thinking about other things again. And so these are the kind of things people would keep on talking about, that some challenge would come along. And what they were used to over years of having the disorders, and a challenge would come along, okay, that's my week gone. I'm going to be stuck ruminating about this for the rest of the week. I won't be able to do anything. And what they kept noticing was like, yeah, I get upset. And then 20 minutes later, I'm over it. And I said, well, is that a weird experience? You feel like you're being emotionally numbed or emotionally blunted? No. I still have my emotions, but I can get over things now. And I don't overreact as much as I used to. My reaction is like sort of, more proportionate. And I find I can, and so what's the experience like? And they use words like willpower and control. They say, I feel more like I'm in control again. I feel like I have that willpower thing that everyone's been telling me I need more of. That their subjective experience of having this network strengthen is an experience of greater willpower, greater control.
And so does it matter which part of the network was stimulated, or were these many different studies stimulating various different parts, but it all happened to be of this network?
Well, so it's been a long time piecing that together because in the TMS literature, different people targeted. Some people would do the left hemisphere, some would do the right hemisphere, some would go in the middle between the two hemispheres and so on. And now that we've got enough of these studies and we put them together, it looks like you kind of get fairly similar results no matter which, as long as it's one of the members of this network of regions, all the other networks are lighting up as well. And so it seems to have a similar effect. When we scan people while we do TMS, you see that when you're stimulating one area, all the other areas in its network will light up.
And how effective is this approach? Is it 90% of patients get better in some way? Is it 10%?
So that's been, remembering that TMS is a technology. So if you asked me the question in 1995, it would be asking a little bit like, well, how far can your electric car drive in 1995 versus how far can your electric car drive in 2025? The good news is there's progress. The early TMS studies were only getting about 10 or 15% of people to remission, but they were also only doing about 10 or 15 sessions of treatment. And then later studies did about 30 sessions of treatment and got about 30% of people better. And then later studies did about 50 sessions of treatment, and sometimes you get 50% of people better. And then other studies were using MRI guidance to kind of fine-tune the location of the stimulation. And it turns out because of their anatomy, you need to map their anatomy a little more closely to get the coil over the right spot. But the biggest breakthrough, I think, in the last 2 or 3 years is noticing that TMS requires, as we mentioned, it requires the brain to have neuroplasticity, right? There are implantable brain stimulators that people use for Parkinson's and depression and so on, and then a surgeon will implant them like a little pacemaker in the target circuit, and then you walk around with it all day long. TMS isn't like that. You sit in the chair, you get a session of treatment for 3 minutes, and after a bunch of sessions, it has to keep lasting for weeks or months, even after you've gotten the treatment done. So the only way that works is if you have neuroplasticity. And some people just don't have very much. We don't know why, but there's a lot of variation. So when we treat a bunch of people with depression, about 20% of people show really strong and really rapid response. And then about 10% of people show nothing at all. And everyone else is somewhere in the middle. It's almost like you're bailing a bit of a leaky boat. So you're kind of bailing it out, but they're getting worse. And then they tend to keep coming back. These are the ones who seem to need more plasticity. And one of the ways that has just come come out in the last 2 or 3 years to make TMS a lot better is it turns out that there are some simple off-the-shelf old medications that enhance the brain's plasticity. And if you take those medications a little, like an hour or so before you get your TMS sessions, it works a lot better and it lasts a lot longer.
Give us a sense of what some of these meds are, just in case the name strikes anyone who's familiar.
Happy to do it. So there is, my colleague Alex McGeer at the University of Calgary back in 2022 published a paper in JAMA Psychiatry using it's actually an old anti-tuberculosis medication called D-cycloserine. D-cycloserine works on the brain's glutamate system. And if we want to get really nerdy, it acts on the NMDA receptor. The NMDA receptor is the receptor that detects whether two neurons are being fired at the same time and then responds to that by strengthening the connection between them. So you need your NMDA receptors to do that whole plasticity thing where the neurons that fire together wire together. So what happens if you add a medication that tickles the NMDA receptor and kind of helps it stay open a little bit longer and then do the TMS? D-cycloserine has been around since the 50s, and psychiatrists have been using it and medical researchers have been using it not for tuberculosis, but to try and enhance plasticity while they give therapy and give other kinds of treatments, exposure therapy and phobias and OCD and so on. And I think one of my colleagues described the results as meh. After many, many years, the result was sort of so. But interestingly, it might just be that those kind of therapies don't provide the direct kind of potent, immediate stimulation of the neural connections the way that TMS does. Because the first time this was tried for TMS, the effect was not small. It doubled the remission rate. And that was just giving it for the first 10 out of 20 sessions of TMS. Instead of the 20% remission rate you might expect with 20 sessions, it went up to 40%. And then actually just 2 months ago, Alex McGeer's team went back and they tried it again for all 20 sessions. And the remission rate went from 20% to 70%. 85% of people showing at least that. So it turns out there are a lot of people who just need more plasticity to do well on TMS. And TMS actually can be extremely powerful if you just enhance the plasticity first. So that was, and then of course, is this just about depression? So he also went to a different brain area, but was involved in OCD, because there is a TMS protocol for OCD. OCD is a tough nut to crack. Among TMS researchers, we think of
that's obsessive compulsive disorder.
Obsessive compulsive disorder is reckoned to be one of the toughest things. Just for when they do clinical studies on OCD, they will often declare 35% improvement in symptoms as a strong response. We don't expect to cure you of your OCD. If we can even get you 35% better, we'll call that a win. That's often how studies are done. Alex McGeer's team, when they did this in OCD, they found that 20 sessions, there's a scale from 0 to 40 called the Yale-Brown Obsessive Compulsive Score. It's the standard clinical scale you use to measure how bad somebody's OCD is. And, you'll have a person who might have a score of 26, which would be severe, or 30, which would be very severe. And 20 sessions of TMS would reduce their score by about 2 or 3 points. But with D-cycloserine, it was closer to 10 points of reduction in 20 sessions.
Great.
So it's a big difference. And, the question is, well, okay, TMS is used for lots of other things. Like TMS is being used for other brain circuits and Parkinson's and Alzheimer's. So could this be used to treat lots of things? There's a second way of enhancing plasticity, which is dopamine. So dopamine has a lot of roles in the brain, but it does look like TMS relies upon dopamine for at least some of the plasticity. And there have been studies done both in laboratory and in the real world in which if you give people medications that boost their dopamine levels, like L-Dopa, for example, a Parkinson's drug that adds dopamine to the brain, and then you do the TMS, the excitatory TMS protocols get stronger. The effect of the TMS gets stronger, so you're boosting plasticity. So it looks like there's at least 2 or 3 different receptor and neurotransmitter systems that can be used to do this.
How about acetylcholine?
That's an interesting one. So that hasn't been tried yet, but there are easily 4 or 5 or 6 different methods for doing this. I don't know if you've had Lee Williams come in and talk. So Lee Williams here at Stanford has been looking at guanfacine. So not necessarily on acetylcholine, but looking at guanfacine to see that's a third neurotransmitter system involving norepinephrine, and has been showing that people with there are specific people with depression who stand out for having particularly prominent difficulties with cognitive control. And here's a medication called guanfacine that isn't normally used as an antidepressant, but in these patients, who happen to have what they call the cognitive control deficits, this medication does work as an antidepressant for these folks.
Incredible.
Probably by enhancing their cognitive control so they don't get stuck in rumination all the time.
Right.
Yeah.
You know, this is such an exciting moment in time we're in neuroscience, where everybody has been doing these studies, and we well know that to get a patient and do a study and so on, it's a ton of work to do one patient, two patients, and suddenly we can do these meta-analyses and put together the big picture and start seeing the jigsaw puzzle more broadly. So what are next steps? We're almost halfway through 2025 now. Where's this all going?
Absolutely. So first of all, there are two directions that the field is going in right now. One of them, which I think is a broader trend in psychiatry in general, is the field of personalized medicine. So let's look at your symptoms and let's see if we can achieve a higher chance of success by looking at your specific symptoms and personalizing maybe the frequency of treatment or the type of medication we use or the location of the coil based on your specific parameters, which is great if it works. But the downside, of course, is it also adds a lot more complexity. So, psychiatric treatments are already costly and hard to get, and so this makes them more costly and more hard to get. The other potential approach that we could try, not to say that then there's certainly going to be a role for that. Personalized medicine is certainly looking very exciting. But there are some things, there's a different approach where we try not to personalize and when we simply try to come up with a sort of greatest good for the greatest number approach. And so I want to unpack that a little bit to point at the idea that there might be some brain circuits. I mentioned earlier there are some brain circuits that are universally involved across a variety of different disorders. And so one of the questions I asked one of my colleagues at Harvard who had been doing one of these brain mapping type studies and saying, instead of mapping the circuits that are associated with depression or PTSD or addictions or whatever, we noticed that some people just have resilience. So they actually function much better than expected. Like for those of us who work in clinics and see thousands of patients, you'll see these people who have like terrible depression and yet somehow like they're still functioning really well. Or people who have terrible Parkinson's and can barely move and somehow they're still kind of functioning. Or have had a stroke that's crippling to them, and as we mentioned earlier, are somehow still functioning. And then
functioning mentally.
And in the activities of daily life. Like, yes, they're super, but they're somehow still, I actually saw a gentleman, what was it? I don't know his name. We were having brunch in Palo Alto, just up the road. And there was a little man, he looked in his 90s in a wheelchair by himself, and he was out for a walk. He was using one leg and his heel to drag his wheelchair along 1 foot at a time. And he smiled and waved to us, and he kind of crept along the sidewalk for his morning stroll. And I don't know who got him into the chair or how he was getting along, but there he was just using 1 foot to drag himself around the block for a morning stroll. And so we can evaluate how severe your symptoms are, but we can independently evaluate how well you're functioning in daily life. So that gentleman I mentioned would be an example of someone who, if you measured their physical symptoms, they would be totally crippled. But if you actually, they're still getting up every morning and walking around and having breakfast and doing all their stuff. So on that level, they're better than expected. So the question becomes, let's run an analysis of strokes or lesions or other things and figure out, are there areas that correlate with your better than expected or worse than expected number, if we think of it that way. Yeah. And they pop out. And there are two circuits that popped out of that analysis, which was led by Beatrice Milano and with my colleague Sean Siddiqui and his group over at Harvard. They went through a whole bunch of stroke patients and they looked at, their ability to function in general. And the circuits that popped out, number one, involved one of these salience network circuits that I talked about. But there was a second circuit that was down just above the eye in another circuit we haven't gotten to yet called the orbitofrontal cortex. And it was also involved, but in the opposite polarity. In other words, it was actually good to have lesions in this area. And if this area was preserved, you were more likely to be functionally impaired.
How do we understand that?
So that's an interesting one because this circuit is also pretty well studied, and it is the counterpart to the brain's so-called reward circuit. So the brain, most of us know, has a sort of a reward circuit whose job it is to identify goals that are worth pursuing and to motivate us to go and pursue those goals. The problem is that would only allow us to pursue positive goals. We also need a partner circuit to identify potential pitfalls or problems, challenges, threats, and to establish goals to avoid those things and motivate ourselves to avoid those. If you don't have both circuits, you're in trouble because the brain needs to be motivated to seek out stuff, but also needs to be motivated to avoid the bad stuff. And the circuit that was overactive in these stroke patients, or so to speak, or that was the one that was the so-called non-reward circuit, the one whose job it was to be motivated to essentially to generate negative motivations. It looks like.
Sorry, you said that was overactive in the stroke patients, or it was
There's a specific thing we think is happening in that circuit. It can enter into a feedback loop, right? And this is a theory by a professor in the UK called Professor Edmund Rolls. He'd been studying the orbitofrontal cortex region in monkeys and humans for decades. And he, after many years, realized that this circuit tended to get stuck in a feedback loop in depression. And he proposed what I think is a very lovely theory called the non-reward attractor theory of depression. So in the non-reward attractor theory of depression, you have a circuit whose job it is to, when it's functioning properly, is to identify a threat so you can then start to think about solutions and go and solve them. But if it gets stuck in a feedback loop, then you can't stop thinking about it, even when you're not solving it. And I think all of us have experience the sensation at times of the difference between, working on a problem versus just worrying about a problem, where you're not really solving it, but you're awake at 2 a.m, you're just thinking about the same thing over and over and over again, and you're not really getting anywhere, but you just keep going, and you can't get back to sleep. And you really just need to stop thinking about it, because you're not going to solve it right now, and snap out of it and go back to sleep. Now, if you can't, and if that goes all day long, you're not functioning, because you're sitting there ruminating and going round and round on problems. Maybe it's a 1 out of 10 problem that your brain is treating as a 10 out of 10 problem. Maybe it's a 3 out of 10 problem that your brain should be spending 5 minutes on, and instead it's spending 8 hours on. But the point is that while it's doing that, you're not getting up, you're not having breakfast, you're not functioning, you're not going to work, you're not fully present, you're not doing things. I'll give you an example of this. There was a woman described in the literature who she, among other things, had sought treatment for many years for alcohol dependence. So she was somebody who drank about 10 drinks a day and somehow functioned through this reasonably well, but was drinking 10 drinks a day and had sought treatment from physicians for this in a variety of different ways, none of which had been successful. In her 50s, she suffered a stroke. And the strange thing was the stroke happened to land it was a small stroke just in this little circuit. And she immediately found that she no longer had any desire or interest in consuming alcohol. And the alcohol use that she'd been trying to get over for years just kind of went away. Other people with strokes in these areas, there are people who have obsessive compulsive disorder and have suffered, this is a weird thing, that they've had OCD for 30 or 40 years, and then one day they have a stroke in their old age and the OCD goes away. So, so there are situations where this circuit gets stuck in a feedback loop, and the best thing you can do for your function is to just get out of the feedback loop. Now, losing the circuit altogether is pretty drastic, right? That's what we'd rather do is just turn it down a little bit. And TMS can be used to do that. Back in around 2016, 17, I had a patient who had come for TMS, and we tried the standard TMS of one of these salience network regions, and we didn't get anywhere. So then we tried another salience network region, and for reasons you and I have described, that didn't do much either. And then she said, well, please try something else, because the next step normally would have been to go to electroconvulsive therapy or shock therapy, and she really didn't want to do that. So I said, well, there is this other area that's been tried in OCD, and you don't have OCD, but you do have a kind of depression that reminds us of OCD, because you just kind of get obsessed with the same negative things about yourself. And when you describe to me what your depression is like, it sounds almost like an OCD-ish flavor of depression. So if you like, you can come in and I'll give you this treatment, which has been used for OCD, and we'll say let's see if your OCD-ish depression get somewhere. And it was a complete remission. We also had scans on her, and we were able to show that normally when we do TMS, we strengthen the salience network, and you can see this connection strengthened. In her case, we scanned her before and after, and when she got better, it had nothing to do with the salience network. Instead, we had suppressed the overconnection between this orbitofrontal region and its little loop of activity down into the reward circuitry.
So what happened to her afterwards? What was it like for her?
What she said was that essentially she was now free of ruminations. I'll give you and we had other people come and do it, so I'll give you a really illustrative example of one person who had a little bit of both. She had a bit of column A and a bit of column B. So not only did she have a tendency to be really obsessive and self-critical and ruminative, but she also tended to be quite impulsive and a bit ADHD-like and had difficulty with the cognitive control. So she really struggled. And she came to us from the eating disorder program, and she had bulimia nervosa. So she would spend a couple of hours a day binge eating and then purging it up and binge eating and purging. She also had a lot of intrusive thoughts about her body image and negative body thoughts. She had PTSD symptoms. She had a lot of different things. So we gave her the standard TMS, and her depression scores went down by about half. And she said, well, this is really interesting. Like, I feel somewhat better. Like, I noticed, like, I'm feeling less anxious and less depressed. And you certainly helped me with my bulimia, because I haven't had any urges to binge or purge. Like, those impulses are just gone. But I still think about suicide every day. And I still think about how horrible my body looks every day. And I can't enjoy anything. And so we talked about it a bit, and when I heard about these obsessions, I said, well, we could try going to this other area that's typically an OCD area and see if these obsessive thoughts you have about body image and suicide and so on, let's see what that does, because a couple of other patients have been helped by it. It was a while before we could get her in. The clinic had a lineup, so we treated her. And then she came back in. This is lovely. She came in and I asked her how she was doing, and her scores were down to the single digits. She was doing really, really well. And I asked her, but what was it like? And she said, well, I'll tell you what I noticed. It was this past weekend. I was playing with my niece and nephew, and I noticed that I was smiling. And I noticed I was feeling pleasure, like joy, which is weird. I haven't felt that in 20 years. And then I thought about it, and I realized I actually hadn't thought about suicide all day. And that hasn't happened for 20. And I realized I hadn't thought about suicide for days, which hasn't happened. I was able to enjoy things. And then I realized I'd eaten a hamburger 4 days ago, and normally I'd still be thinking about that hamburger.
Thinking about her regret about eating the hamburger.
Exactly. Yeah. I'd still be thinking, like, why did you do that? And I realized that I just wasn't worried about the burger. I'd eaten it, and I was a little upset about it, but then I just wasn't thinking about it anymore. But this was 3 or 4 months after her original treatment. She said, but could I come back and have the previous one again? Because I'm starting to get back into my binging and purging behavior. That part is coming back again. So you can see what we would call in neuropsychology a double dissociation, where treatment of one circuit is helping with the person's impulses and their cognitive control. And after the treatment there, she felt a stronger sense of agency, of self-control with this first set of areas around the salience network. With the second set of areas, she was feeling freedom from being trapped in a circle of rumination on negative thoughts. But as the first one wore off, she was losing that control piece. And that highlights the two elements of resilience that come from this. What the ingredients of resilience seem to be these two circuits. Number one, having more self-control or agency or a sense of will to snap out of things or control what you're thinking about. And number two, the ability to not get stuck in a circle of rumination on the same stuff, the ability to exit that circle. If you have those two things, you're resilient.
So cut to a quarter century from now, when this is all very well worked out and every shopping mall has a TMS clinic that you can walk into.
I hope we're there soon. Yeah.
Okay. The question is, how will people know whether they should go in and get this treatment? It's like doing a tune-up on your car, but how do you know, is there some variety that would be useful to have in our society? How do you know when you should get it, at what level?
Yeah, it's a really interesting question, particularly because TMS is a technology, so it gets better, it gets faster, it gets cheaper over time. So, as the example of, when I was a kid, we talked about flying to, like, space tourists who would go up to flying space hotels, and that hasn't happened yet because the cost of flying to space would have to come down a lot before most of us can afford to do that. And likewise, TMS presently is still pretty expensive, but, the costs are coming down and the availability is going up, and so the threshold and TMS happens to have an excellent safety profile. So the question would be of when to go and get TMS. Right now, it is an FDA cleared technique, and the FDA has declared it to be a prescription treatment. So one does go to a physician and obtain a prescription to get TMS. And in the past, most insurers and payers would require people to have tried 3 or 4 or 5 or 6 different medications before often 4 medications or more before they were allowed to apply for coverage for TMS. Now those numbers are coming down, and people are able to go earlier on. So I think what we'll see is that it may be that you'll be able to go for TMS to enhance your functional capacity, just knowing that we have these two target circuits. People will be able to go in and across a wide variety of disorders. So at the moment, TMS is FDA cleared in depression, it's FDA cleared in OCD and in chronic pain, and a couple of other conditions. But what might happen is it might be cleared across a wide basket of different conditions. And because the TMS really isn't, what's interesting is we've discovered the TMS isn't treating the depression. It's indirectly treating that by just generally enhancing your self-control and allowing you to not get stuck in rumination. And that turns out to be useful not just for depression, but for lots of things. So where I hope we end up in hopefully a lot less than 25 years, maybe in 5 years, would be in a situation where people can come in across a wide variety of conditions, and maybe not waiting until they're extremely severe and until they've tried lots of other things. But, there may even be a world where, and this is one thing people are working on, is even before going to medications, where people might be able to go and pursue this treatment right away. So when a person first starts to realize that they're encountering significant difficulty functioning because of the severity of their anxiety or depression or whatever it be, that they can go in and get essentially a top-up of resilience, the thing that we all wish we had. And that comes back to a dinner conversation we had 10 years ago where I was sitting with some friends, and as a dinner conversation starter, we said, okay, let's go around the room, and let's say you had the ability to just rub a magic lamp and a genie you could say one word and then everyone in the world would be gifted that thing. So what would you, and we all went around the table, and the one I chose happened to be resilience. I said, if the world would just run better if we could all have a little bit more resilience. So I would love to get to a world where we just generally have this treatment that enhances one's ability to be resilient. And if we could get that out to everybody with, a relatively short treatment. Not that we shouldn't also, people can go and do mindfulness and cognitive therapy and all these other things. And that takes time and skill set. It's like piano lessons. You've got to put in your time and your hours to do it. But I think those piano lessons will go faster for people if we can draw upon their inner strengths. Let's pull out your maximum, because we all have these circuits and we all have neuroplasticity. So every human being's brain, as you've discussed many times, has the ability to rewire and change itself. And every human being has somewhere in those circuits that allow us to do cognitive control and to escape from rumination and so on. These are all inner capacities that are within all of us. In some of them, it's on the surface, the highly resilient people. But in people who aren't feeling resilient, or people who do have these axis 1 disorders, it's not that they don't have that capacity. It's latent, it's hiding. And we're now having a capacity by combining targeted brain stimulation with neuroplasticity enhancement, we can bring out the person's inner strengths. And I think that's something that is just, I wish if we could have everybody listening to this just know one thing, is that all of us have these inner strengths inside us. And some of us has been hidden and dormant for a long time. But I think in every one of us, those abilities are there, and we can bring them to the surface.
That's beautiful. Let me just ask one last question I wanted to come back on, which is the influence of our social lives on resilience.
That's beautiful. And I'm really glad you brought that up, because up until now, everything we've been talking about with resilience are like the human atom. It's just sort of for individuals in isolation. It's one human brain just by itself, a bunch of circuits inside a skull. But we don't live as little atoms. No human is an island. We all we live within a broad social fabric. And I think you can delve into any number of beautifully written books on resilience. We'll talk about one of the greatest and most important things supporting a person's resilience is the social supports and fabric that they have around them. Most challenges can be faced if they're not faced alone. I think I talked to a colleague of mine, and he talked about how his favorite part of medical training was actually in medical school, which some people see as the toughest part. He said, but the thing is, I had these two buddies, and the three of us, we did all our studying together. We worked through it. We were these comrades, and we felt like when we faced the world, we were unstoppable. Like, it was a very stressful thing going through training in medical school, but as long as I had my two buddies with me, we could face anything.
Yeah.
And I think a lot of us have had that experience. So there's been, as you know, a tremendous amount of research done on the importance of social fabric and social supports and a strong social network.
Well, so what would you recommend for people? What do you recommend for people in terms of building a social life?
Well, it's tricky because I think there's certainly been a shift over the last decade in terms of how people spend their time, and if everybody else is just locked away on in solitary activities of one type or another, then it's harder and harder to go out there and find people to do social things with. But I find that the way people build social communities is often either through mutual connections or through mutual activities. So you can meet friends through other friends, and so friends are good at introducing other friends, and activities are also good at introducing and connecting people together. So one way you can kind of get two birds with one stone is, running clubs have become incredibly popular. Just to take one random example of ways that people have decided to sort of quit dating apps and instead just go out and go on these big running clubs. And this is how young singles are kind of meeting each other, is by finding some kind of activity in common. But whether you fall into that category or not, I think there are, a variety of different websites and so on out there. Like meetup.com is an old one that's been around forever. I thought it was quite clever, the idea that you would just have various activities and people could connect over an activity or an interest that they had in common. So I think whether it's reaching out to a faith community, if you're somebody who follows a particular faith, or whether it's an interest group, or whether it's a physical activity like exercise or running, I think finding activities to connect with other people who have that common interest is a really, really great way of strengthening your connections with other people and finding common purpose. Among cultures, it's interesting if you go read up on the culture of Okinawa. Okinawa's is identified as one of these blue zones where people live unusually long and so on. But one of the interesting things that they talk about is the unusual psychological resilience of people in Okinawa. And the concept of which I was introduced to recently was that I'm probably going to say it wrong, but ikigai is there's a word ikigai. I'm probably going to butcher this, but as I understand it, it is the idea of having a purpose or a calling or a cause. Mm-hmm. And part of the culture there is that, and it could be something incredibly small, just like literally like raking a beach and keeping it tidy, or it could be something large, like trying to save the world from a resilience deficit. It could be anything whatsoever. But the idea that part of resilience involves making sure that your life is imbued with meaning and that you have some kind of compass or some kind of guidance to it. And so I think if you can find that activity that you choose with the people around you to be a meaningful activity, something you find that gives you purpose and meaning in life, that carries ikigai. And if on top of that, it's not just a personal meaning, but if you can then use that as a nucleus to build a community of other people around that common purpose, there is incredibly resilience to be had in being a member of a community of other people, all of whom are dedicated to a common and meaningful cause. And I think if you don't have access to a TMS machine, I think that's certainly the compass that I would lean into.
That was my conversation with Jonathan Downar. So, what is resilience? We've long thought about it as a psychological trait. We talk about grit or determination or optimism. But what today's conversation hopefully makes clear is that resilience has a physical footprint in the brain. It's not just about what you choose to think, it's about how your networks are operating. It involves a carefully orchestrated interplay between brain areas involved in emotion and reward and control and so on. And these brain networks can tip the balance between breaking down and bouncing back. And I think this is some of the most exciting and practical work happening in neuroscience. People are identifying these circuits and they are influencing them using tools like TMS. And this can, when it works, enhance a person's ability to function across a whole spectrum of disorders. And so one lesson that emerges is that resilience isn't just something we summon after disaster strikes. It's something we can build ahead of time. It's something we can cultivate in the brain like a form of mental infrastructure, one that helps us face whatever is coming down the pike next. And as our knowledge improves and the technology improves, this all may eventually lead to a paradigm shift in mental health. Instead of treating one disorder at a time, like depression or anxiety or PTSD, what if we focused upstream? What if we tried to increase resilience itself across the board? Of course, biology is only part of the story. Social support, culture, personal meaning, these are all powerful factors and addressable factors when we're thinking about resilience in our lives. But it's amazing to realize that even in the hardest moments, the exact state of the networks in your brain matters for the degree to which you can be an active participant in recovery. Maybe if we come to understand resilience in the brain and psychologically and socially, we can help more people to thrive. So thanks for tuning in today. If this episode moved you or challenged you or sparked questions, I'd love to hear from you. Pop me an email at podcast@eagleman.com. And if you ask me to, I can pass your note on to Jonathan as well. And if this episode made you think about someone in your life who embodies resilience, please share this episode with them. Science is catching up to something that people have known in their bones for a long time. The mind can bend without breaking, and sometimes in that bending, it gets stronger. So until next time, take care of your brain so you can take care of each other. Go to eagleman.com/podcast for more information and to find further reading. And check out and subscribe to Inner Cosmos on YouTube for videos of each episode and to leave comments. Until next time, I'm David Eagleman, and this is Inner Cosmos.